Okay, good evening, everyone. I'm Priya, one of the organizing co-chairs, and I welcome you all to the third day of week one of IEEE Symposium on Data Analytics and Internet of Things. IEEE Victorian section presents this symposium in collaboration with Computational Intelligence Society, IoT Community, and University of Melbourne Student Branch. Just to quickly run you through the schedule of the symposium, it's going to run for 7 more weeks until 19th of November, with events happening only on Tuesdays, Wednesdays, and Thursdays, either as afternoon or evening sessions. However, most of the sessions have been organized in the evenings. Since you have registered for this week, you will be on our emailing list and you will receive emails about the event schedule for all of the following weeks. You can also follow our website and social media pages for more updates. So today is a third tutorial talk on Internet of Things, and the topic is applications and advancement in smart grid and renewable energy. The talk will be for about 45 minutes with last 10 minutes dedicated for question and answer session. Please use the question answer tab at the bottom of the window to post your questions. And we have Dr. Shama Islam as a speaker for this event. Shama is a senior lecturer in electrical engineering at Deakin University and is a leading researcher in the area of smart grid communication, IoT and data analytics for smart energy applications, energy management, and wireless communications. She has received Future Women Leaders Award from Monash University in 2017. She has also been awarded Victoria Fellowship 2019 for contributions to scientific innovations in Victoria. Currently, she is also serving as the chair of IEEE PES Victorian chapter. Thank you, Shama, for joining us. The floor is all yours.
Thanks, Priya, for introducing me, and thanks a lot for organizing this amazing series of events. I believe that it will be really helpful for the technical community to be part of this IoT symposium.
Thank you.
Okay, so let's I'll share, just make it full screen. Yeah. So today I'm going to talk about the applications and advancements of IoT in smart grid and renewable energy, because this is my research area these days on the smart grid and renewable energy sector. Before starting the talk, I just want to mention that I'm aware that there have been two talks in the last 2 days, and they may have already covered a lot of aspects of the IoT architecture. So my intention is mainly to focus on the renewable energy side, but from time to time, I will also mention a few things about the IoT architecture, just to also ensure that if you have not attended those two sessions, you still get through this with the technical terms and so on. Anyway, but yeah, if anything is not clear, please feel free to post in the chat box, and we can always discuss that. So as you all know, that with the advancement of information and communication technologies, it is now a very common thing that Internet of Things will create a new revolution in today's world, where we can imagine that each and every device will talk to each other, and they will be connected through an intelligent network and assist with intelligent decision making. That's what we call the Internet of Things. So as Internet of Things have revolutionized different sectors, we can imagine that it will also bring new aspects to the smart grid systems, to the energy network. So if you already don't know what is smart grid system or smart energy system, the first question is, how is it different from the traditional energy system? In our traditional energy system, we have like generation, then the electricity flows through the transmission and distribution network to the customer premises. The end users could be residential, commercial, or industrial users. And it's also very common these days that the end users will have distributed energy resources on their premises. So this is basically our power system network. But how this becomes smart? When we have communication flowing through all over it, side by side with the power flow. For example, for the transmission network, we can have a transmission control center monitoring the substation. For the distribution network, another control center, and then energy service provider could provide access to intelligent energy management system, which can help you to identify how better you can utilize your energy. So when the communication network and the power system network, they are completely interconnected with each other, that's what brings us to the smart energy system. And through this improved communication, there is better control of the power system assets, and intelligent decision making is possible. And it goes without saying that IoT can bring a real big advantage for smart energy system, because IoT allows all our devices to be connected through the information and communication network. So definitely there will be advantage when we have IoT in this built in the smart energy system. For example, if we think about the end user premises, we have different distributed energy resources, different types of loads, and this information is monitored through the smart meter, the energy consumption information. This information can be communicated through the base station to this 4G, 5G, or IoT networks. At the same time, there could be this distribution and transmission network which can communicate through this power line communication, and all these information will be combined in a fusion center, and it can make room for different types of communications. Also, there could be information collected from generation, transmission network, distribution system operators, and everything will be combined here so that intelligent decisions can be made by combining the information obtained from each and every aspect of the energy system. So that's how the IoT can bring enormous benefits for smart energy system. So what IoT can offer for energy system, this is a simple example. This is a snapshot which I always like to share. This is part of our Deakin microgrid. So if you don't know, Deakin University has a microgrid in its Warren Ponds campus. As part of that, we have solar panels connected to different buildings alongside a solar farm. So this data is from the building where I used to sit before COVID. And as you can see that from this visualization platform, we can easily see how much generation is going on, how much demand is there, how much we are importing, how much we are performing compared to previous day. Different analytics, different insights can be made available through this kind of visualization, which wouldn't be possible if we did not have IoT in the network. So there are like intelligent devices connected to each building, which can monitor these energy flows. And based on that, it can make intelligent decisions, like how we are performing compared to previous day, previous 7 days, or previous 1 month, and so on. So this data I took today at around 4 p.m. So it was still quite sunny in Geelong. Okay. So many people say and like ask this question because like when IoT is not there, we do have a SCADA system, which is supervisory control and data acquisition system in the power system network, like in many other manufacturing networks, manufacturing systems. We do have this SCADA system where the processes can be monitored through different sensors. Let's say how much is the gas flow, how much is the water level, and so on. And these measurements are collected by the programmable logic controllers, PLCs, and based on that, it can send some control signal for which it is programmed. So it can send this control signal to the different actuators in the plants. And also there is a supervisory control available through the human-machine interface. And the supervisory controller, it is typically monitored by a higher level system. Typically, a human can intervene it. For example, it can make intelligent decisions such as like based on the load demand, how much generation needs to be dispatched. So higher level decisions, those come from this supervisory control system. So this has been there in the system for around 60, 70 years. But then why we're saying that IoT can be bringing further advantage in this network? As IoT enables more monitoring through the internet, so it will bring more flexibility, because you really don't have to be in the plant or connected to the plant's network for monitoring. If every information is sent over the internet, you can easily look at what's going on in the plant by drinking coffee at your home. And as today, like there are more geographically dispersed resources, and these are located like at different parts. Let's say some of these generation assets may be 1,000 kilometers apart. How do you monitor them simultaneously? It's not possible for everyone or for every organization to have someone dedicated to regularly monitor how things are going on physically on those plants or on those assets. So often it is useful if you have the remote monitoring available through internet. So ultimately it can be cost effective as well. Otherwise you don't have to, you'll have to send send someone to those resources on a regular basis. But the biggest advantage I would say is, like, when you connect all this information over the internet, you can integrate machine learning and data analytics algorithm much more easily, which can bring new advancements of how you make decisions, how you monitor your network, how you can bring benefits to the overall operation of this business. So I definitely can say that IoT definitely can augment the existing SCADA system and can bring new features and advances which can bring us to the new era of data analytics and information processing. Here is an example of how IoT is used in distribution network monitoring. If you're not familiar with the term phasor